All right. So second talk is on benchmarking. This is an idea that came around somewhere this January. I was needing a benchmarking library that I could easily work with, but it turns out it's quite complicated to use anything pre-existing because of the boilerplate that is involved. So came to the point, like, what if we could create a library that requires minimum boilerplate? As you can see here, there's quite a bit of a code for the setup and only a little bit of a code of the measurement. So we'll get to it, like what that actually means. So all the setup is boring. It's detailed. So far, I could reduce this setup quite a bit, but it requires more work. And this basically means to create a mock library that could provide the data given the context. Strings and matrices and whatnot. I already began work on this one and probably will talk about it some other time. However, the actual productivity, the actual measurement part, it checks out, and it turns out that if you do things right, then the C++ as a language can be used to measure C library performance. And in this case, it's only a few liner to measure the string IO performance of fixed length strings of the original C library. For this one, I use lambda expressions and a single function that throughput function that you can see here is basically it takes arbitrary arguments in arbitrary order, similarly that you would get in Python. Using template metaprogramming, breaks it up into pieces and generates the correct code. The transfer data size needs to be returned in order to compute the actual throughput, but that's all the limitations. The test suite names and the iterated values, such as behavior, can be controlled. All in all, once the transfer data size is computed, then we can actually get the throughput. So this is a minimum boilerplate, and because of a property of H5 CAPI library, handles are binary equivalent with the original HDF5 C library. You can always simplify the code to fairly small size. There is no need to set up and break down libraries. The RAI component of the H5 CAPI can do it for you. Data sets still is a problem, and I work on a mock library that will reduce these ones. But basically, you can pass arbitrary data through the capture class of the lambda expression, and that also results in further simplification. The type descriptors can be modified, and the house will be talked about tomorrow in H5 CAPI presentation. And here is the result. It's a regular comply flags for C++ 17. There's not much to mention, except the linking against the HDF5 library and an CPU affinity flag that is suggested to use in order to reduce the variance of the final result. And here is the output, which is produced in text format or in HDF5 for massive, scalable benchmark text. Knobs and levers. We all want to change things. So one of them is the past argument list. In the x-axis actually supports up to 3 arguments or 3 dimensions. In this case, we're testing 10 to the 4, 5, 6, and up, and do the measurements. There is a way to do burn-in iterations or warm-up that are discarded, and the actual samples, in this case, is only 10, but usually you want to have at least 100 measurements or so. Here are some features. Intuitive syntax is one of them, and a significant reduction in boilerplate. And most importantly, the ability of writing your code in simpler C++ and use test C library calls. So that's in a nutshell. Thank you very much.
Thank you, Stephen, and thank you saving time. We probably have just time for one question.
If anyone has a question or observations.
It's great to see to reduce programming effort to do benchmarking. This is really neat.
It's a process, indeed, Alina, and there are missing components. On a different side, I work on the mock library that allows arbitrary random data generated. So all you have to do is just query, get a vector, get a tree, or get a massive matrix. Some of them are easier, the others are much harder. Strings are more complex to generate randomly for the desired structure and the size. And all of them, preferably, if possible, at compile time, so you can use compile time libraries or metaprogramming based functions to use this library. And this is the consumer end where I should actually test the function. So this is all. If anyone has questions related to performance issues in the C or C++ library, you can find me on the C++ forum, and using this library, I more likely will point out what sort of improvements you can do with your code snippet.